We know that the compounds are formed by the combination of atoms of different elements. Now we observe some molecules. HCl, hydrogen chloride. In this, one hydrogen atom combines with one chlorine atom. Water, H2O, two hydrogen atoms combines with one oxygen atom. Ammonia, NH3, three hydrogen atoms combines with one nitrogen atom. Methane, CH4, four hydrogen atoms combine with one carbon atom. From this, what we can understand? During the formation of the molecules of the compounds, atoms combine in certain fixed proportions. This is due to the fact that different atoms have different combining capacities.
The combining capacity of an atom with a hydrogen atom is called valency. Valency of hydrogen atom is taken as 1
and is selected as the standard, and valencies of other elements are expressed in terms of hydrogen. Now we take these examples again. Hydrogen chloride. In this, one hydrogen atom combines with one chlorine atom. That means
valency of chlorine is 1.
in water, two hydrogen atoms combine with one oxygen atom. That means oxygen is having a combining capacity of 2, that is valency of oxygen is 2. In ammonia, three hydrogen atoms combine with one nitrogen atom. The combining capacity of nitrogen is 3, therefore
the valency of nitrogen is 3.
Methane, four hydrogen atoms combine with one carbon atom. The combining capacity of carbon is 4, since it can combine with four hydrogen atoms. Therefore,
valency of carbon is 4.
Valency is nothing but the combining capacity of an atom. In this case, we have taken with respect to hydrogen. This is okay. We defined valency on basis of hydrogen atom. Suppose if the element do not combine with hydrogen, then the valency combining capacity of the element is also defined, that is in terms of other elements like chlorine or oxygen. This is because almost all the elements combine with chlorine and oxygen. Now we take
valency with respect to chlorine.
It is 1. The combining capacity of chlorine with hydrogen atom is 1. Therefore, the number of chlorine atoms with which one atom of an element can combine is called its valency. For example, if we consider sodium chloride, one chlorine atom combines with one sodium atom, hence the valency of sodium is 1. Similarly,
valency with respect to oxygen.
In another way, valency can be defined as double the number of oxygen atoms with which one atom of an element can combine. We know that valency of oxygen is 2. Therefore, if any element combined with oxygen, its valency is considered to be 2. For example, we consider magnesium oxide, MgO. One magnesium atom combines with one oxygen atom. In this case, what is the valency of magnesium? Yes, it is 2. And one more important thing, certain metals exhibit more than one valency, that is, they can exhibit variable valency. Next one is ions or radicals. An atom or a group of atoms, when they lose or gain electrons, gets converted into ions or radicals. Ions formed by the loss of electrons are positively charged and are called cations or positive radicals. And ions formed by the gain of electrons are negatively charged and are known as anions or negative radicals. To understand the concept of these ions, we take the atomic structure. We know that a matter is made up of tiny particles which are called atoms. The meaning of atom is which is indivisible. If we consider an atom, the fundamental particles that present in the atom are neutrons, protons and electrons. Electrons are negatively charged, protons are positively charged particles. At ground state, in an atom, the number of protons and the number of electrons are equal. That means the number of positive charges and number of negative charges are equal. Hence, the charge of atom is 0. If it loses one electron, then what happens? Yes, the number of positive charge particles increases. Hence, it gets positive charge. That means, if an atom loses an electron, it gets positive charge. It becomes positive ion, which is called cation. Similarly, if one electron is added to the atom, then the number of electrons, that is, number of negative charges increases, so that the atom gets negative charge. It is called negative ion or anion or negative radical. Why they lose electrons, why they gain electrons, this we discuss later. Initially, just you remember, when an atom loses electron, it becomes positively charged. When it gains electron, it becomes negatively charged. An ion or radical is classified as monovalent, divalent, trivalent or tetravalent when the number of charges over it are 1, 2, 3, 4 respectively. Here is a list of ions and their charges are given below. Sodium, it is a monovalent. It is represented by Na plus. Potassium, lithium, all these are monovalent and they are represented by a positive sign as are seeing in the figure. For potassium it is K plus, lithium Li plus, calcium, magnesium, zinc, these are divalent. They are represented with plus 2 suffix. Aluminium and chromium, these are trivalent. They are represented using plus 3. Some metallic elements show variable valency, that is more than one valency, and form positive ions with different charges. In that case, the ion with lower charges gets OUS suffix and ion with higher charge gets IC suffix. The value of charge ion is shown by Roman numerals. For example, if we consider copper, copper can form Cu plus, Cu plus 2. The Cu plus, this is called cuprous. That means with lower charge it is OUS suffix. With higher charge it is IC suffix and Cu plus 2 is cupric. Simply this also can be written as copper 1, copper 2. Iron, Fe plus 2, Fe plus 3. Fe plus 2 is called ferrous or iron 2. Fe plus 3 is ferric or iron 3. Tin, Sn plus 2. This is called stannous or stannum 2. Sn plus 4. Stannic, stannum 4. Mercury, Hg plus, mercurous or mercury 1. Hg plus 2 is mercuric or mercury 2. Lead, Pb plus 2. The lower is Pb plus 2. The name is plumbous or lead 2. Pb plus 4. This is higher charge. This is plumbic or lead 4. Now we take some of negative radicals. Negative radicals are formed due to addition of electrons. In this case, hydride H minus, fluoride F minus, chloride Cl minus, bromide Br minus. These are all monovalent. Sulfide, oxide, sulfite. These are divalent. Phosphite P minus 3, nitride and minus 3. These are trivalent. Now we discuss about derivation of formula of compounds. Chemical formula of the compounds are derived by considering the number of charges on ions. Certain basic rules are followed for writing formula of compounds. The positive radical or cation is written first, then it is followed by the negative radical or anion. The molecule of any compound being electrically neutral, the total positive charge on the positive radical or cation should be equal to the total negative charge on the negative radical or anion. Now we take some examples. Suppose we consider the compound between A plus and X minus to form neutral compound with A plus and X minus. Therefore, the total number of positive charges should be equal to the total number of negative charges. As the number of charges on A and X are the same, one atom of A combines with one atom of X to form a neutral compound with A plus and X minus. The total number of positive charges should be equal to the total number of negative charges. As the number of charge on A and X are same, one atom of A combines with one atom of X to form neutral compound AX. For example, we consider the formation of sodium chloride. Na plus and Cl minus, they combine to form NaCl. Molecular formula of the compound is NaCl, that is sodium chloride. To form a compound between A plus and X minus 2. Now to make a neutral compound, by combining these two, how many atoms of A should combine with X? Yes, since its valence is minus 2, two of A atoms should combine with X to get neutral compound. Therefore, the compound formed is A2X. Suppose we take H plus and S minus 2. With these two, the molecular formula is H2S. What is this? Hydrogen sulfide. Next we take another example. To form a compound between A plus 2 and X minus 3. In this case, if you take one atom of A, the charge is plus 2 and this charge is minus 3. They are not equal. If I take two atoms of A, the charge is plus 4, but X is having minus 3. Therefore, two atoms cannot also combine. Suppose we consider three atoms of A, two atoms of X. Then charge on A is plus 6, charge on X is minus 6. Then they combine to form a compound. The compound formed is A3X2. For example, aluminium plus 3 combines with SO4 minus 2 to give a L2SO4 taken thrice. Similarly, Si plus 4 combines with O minus 2 to give SiO2. Ca plus 2 combines with CO3 minus 2 to give CaCO3. These methods for writing formula of the compound can be simplified with the help of crisscross method. The above methods for writing formula of compounds can be simplified with the help of crisscross method. Now what is this method? In step 1, the symbol of the cation or positive radical is written on the left side and the symbol of anion or negative radical is written on the right side. Suppose we consider the formation of H2S and calcium fluoride. H and C are positive radicals. These are written on left side. S and F are negative radicals. These are written on right side. Now you indicate the number of charges on the ions or radicals. H is plus 1, Ca is plus 2, S is minus 2, F is minus 1. And now the value of charge on the ion or radical is interchanged and shifted to the lower right side of the ion or radical. Suppose if I take this 2 is shifted to this position and 1 is shifted to this position. Therefore, with the combination of H plus and S minus 2, we get H2S. With the combination of Ca plus 2 and F minus, we get CaF2. If the charge on any one ion or radical or both the ions and radicals is 1, then no number is required to be written after the interchanged or shifted to the lower right side. For example, K plus 1, Cl minus 1, both are having 1, we get KCl. NH4 plus 1, Cl minus 1, we get NH4Cl. Both are having same charge. Similarly, Fe plus 2, O minus 2, both are having same charge. Due to the combination of these two, we get FeO. Al plus 3, N minus 3. Here also the charges are same. We get Aln. If one of the combining species or both the combining species are polyatomic, then the radicals are written within the brackets. In the case of number of radicals present in one molecule of the compound is more than 1. For example, Ca plus 2 when combines with NO3 minus 1, this gives Ca and O3 2. Suppose if you write 2 here, it related to only O3. Therefore, you have to place brackets and it should be written as Ca and O3 taken twice. Similarly, with the combination of NH4 plus SO4 minus 2, NH4 taken twice, SO4 is formed. In the case of charge of both ions, our radicals have same highest common factor, that is greater than 1. Then both these numbers have to be divided by the highest common factor and the value of the quotient is used. Suppose if I consider Si4 plus O minus 2. Now this is having highest. If 4 is divided with 2, we get 2. Therefore, for Si, this is 1 atom of Si. It combines with 2 atoms of oxygen to give SiO2. Similarly, in case of Mn plus 4 O minus 2, this gives rise to MnO2.